Hello, welcome to software testing methodology. So today we are going to discuss the topic about state testing. So what is meant by state testing? So before that, what is meant by state graph? So state graph I already discussed in the previous chapter. State graph is nothing but it consists of inputs, outputs and transitions. So if we apply the testing on that particular inputs, outputs or entire state graph, it is known as its state testing. So state testing is defined as a functional testing technique to test the functional bugs in entire system. So it is a functional testing technique. So the principles for state testing are very similar to the principles for path testing. So whatever the state graph consists of inputs, outputs and transitions, so path flow graph is nothing but flow graph performing the testing on the flow graph is nothing but the path testing consists of nodes, links and junctions decisions. So same principles will be applied to the state testing and path testing, nothing but state graph and flow graph. So that is the way to define the state testing, and for path testing it is not possible to test every possible path in a flow graph. But in the state testing, similarly for state testing, it is also not possible to test every possible path in a state graph. That is the principles which matches of state testing and a path testing. Now let's see the advantages of state testing. What is the state graph advantages? So the first advantage is nothing but it is useful when the error corrections are less expensive, not too more expensive. When it is less expensive, it is useful. So if the cost is totally high, then it doesn't useful. And when the less expensive, this is one of the advantage. We can say this is one of the advantage of state testing. And it is also useful for when the testers want to detect a specified input. Whatever the input we have to given, whenever the state testing or state testers should be useful. So and these testers want to detect a specified input. In such cases, we will go for one of the way to define the state testing, and it is one of the advantage. Next, coming to the another advantage of state testing is it provides a biggest rewards during the design of the test. So whenever the design cases will go, so this gives the biggest rewards, more rewards during the design of the test. So this is the advantages which defines. So next, coming to the disadvantages. So every testing or every aspect has advantages and also disadvantages. The first disadvantage is nothing but it doesn't provide, means state testing doesn't provide thorough testing, because when a test is completed there might be some bugs remaining to the system. So whenever the test is completed, it doesn't provide entire testing. Every single state will not be tested. That's why it is one of the, it doesn't detect all the bugs in the entire system, and we can call it as this is one of the disadvantage. So next, coming to the second one is testers require large number of input sequences to catch transition errors, missing states, extract states and link. So this you can call it as a one of the disadvantage. So it requires large number of input sequences. Why? Because if you take the states, number of states, what the states, number of states can be defines the possibility of detection of bugs, and it is one of the disadvantage. It has some transition errors or missing boundary, missing states, extra states and the links. So all can be defined as one of the disadvantage. Next, coming to the implementation. How the state testing state graph will be implemented. If the implementation is done, what are the issues rising in the state testing? All can be discussed in the implementation issue. Whatever the bugs in the software can occur through many different cases. So every software testing, any software testing like path testing, state testing, data flow testing, transition testing, transaction flow testing, whatever, state testing, graph matrices testing, whatever, every software can occur through many different cases. Those different cases is nothing but defines the testing bugs, occurrence of bugs based on the software application. And due to these bugs rises, it is impossible to cover all the paths in the state graph. Whatever the state graph defines, it is impossible to cover all the paths. Entire states or entire paths cannot be covered in the state testing. So mainly in that case the bugs will be occur. Mainly the bugs will be occur due to incorrect number of states is one of the main cause. One of the cause for implementation issue when the bugs occur is nothing but incorrect number of states, incorrect state transitions, incorrect transition output and dead states dead states and unreachable states. These are all some of the bugs may occur due to these cases. One is incorrect number of states, incorrect state transitions, incorrect transition output, dead states and unreachable states. So first one is incorrect number of states. So what is the main number of states can be, if there is any number of states incorrected, detection of those bugs can be lead to this type of bug. So state transition, we can call it is a state transition. We can call it is a state transition which defines link between the two or more states. If the link defines the problem, it is an incorrect state transition. So next, incorrect in the input side. Same in the output side, there is some of the transition output side. Incorrect transition output. So it can be defined at output side. So dead states means there is no reachable, or there is no declaration of that particular element or whatever variable. We can call it as a dead state. So next one, unreachable state. So I already told you, reachable means there is a transition between two or more states. If there is no transition between two or more states, just states defined, it is known as an unreachable state. Because of all these issues, the implementation, the state testing will be defined and tested, and the bugs occur in the cause of these situations. So that is nothing but implementation issues. Next, the occurrence of bugs will be more in strongly connected graph. The bugs will be occurred in the strongly connected graph when the system has no state and when there are improper responses, the state diagrams are not applied. So when each and everything is clearly specified, such as transitions and outputs for each state input combination, it would be easy to catch bugs. So that is the way to define state testing implementation issue, and it is considered as a bottom line method as it supports functional model rather than the structural details. So it totally supports the functional model rather than structure. You can call it as a all the implementation issues rises. Next we will go for the testability tips. What are the tips to be followed when the state testing will be defined? So that is nothing but testability tips. So here we follow the two ways. One is switches, flags and unachievable path. The first one is switches. By using the switches, by defining the flags, nothing but flag variables, and unachievable paths. So the switches and flags are most essential tools for testing the state graph. So switch is nothing but the name itself calls switching from one state to the another state. If you take the switch, electric switch, it is a on state and it has two states. One is on state and off state. If the state is a particular direction or position is in on state, then it doesn't go for off state, either one state or the another state. So the flag also same. If you take any one variable, flag variable, then it switches from that variable is the positive direction or negative direction. Like if you take the flag variable A and A bar, A is a positive and A bar is a negative case. Unachievable paths means if there is any path is not achieved, it is known as a unachievable paths. So this is the more essential tools for testing the state graph, and they are used to test the finite state machine in every possible state. So finite state machine, nothing but what in that machine consists of all the inputs which defines finitely. There is some of the limits to be defined, and that outputs and transitions whichever defines from one state to the another state, all the links, and using the switches, using the flags, all you can call it as FSM, is nothing but finite state machine, and these are used to test the FSM in every possible state. So in the early stages of FSM, the flag is initialized and depending on the value specified path is selected to find the easiest path for testing the FSM. So whenever the FSM will be tested, this will go for easily tested by using the switches or whatever the flag variables we are using, like one flag variable, two flag variable. So that defines example program with one flag and program with two flag. So see, only the difference is nothing but same flow graph will be started like node 1, 2, 3, 4 and so on nodes, and KNMO. These are all the data link representations or transition representation from one state to the another state, and this is the flag variable which defines a positive case and negative case like A and A bar. So A and A bar. So this is the flag with one variable. If you take two variables, see this A and B. So two flag variables A and B, A bar, A bar. So for two flag variables also there are two positive cases. One is positive, one is the positive case, and two cases, one is positive case and another one is negative case. For A is a positive case, A and B are the positive cases, A bar and B bar are the negative cases. And see this series rule. Here it applies the series rule and parallel rule. So KLM, this is the series rule like KLM. So KLO, so KLO, this is also series rule. Series rule means multiplication will be done. So this is about flag variable which defines program with one flag and two flag variables. So this is one of the main testability tips to be followed while state testing is performed. Next we will go for essential and inessential final state behavior. So essential is nothing but a most important FSM is used purely based on acknowledgement received. Whatever the acknowledgement is received from another state, if the whatever the state position is changed or behavioral changes, then the acknowledgement will be received and then the next state processing will be done and has no specific logic for implementation without acknowledgement. There is no specific logic for an implementation without the acknowledgement. So I already told that without any specific intimation or confirmation, there is no acknowledgement will be received from one state to the another state. So that is one of the essential way. So even decision table or tree is unable to classify its behavior until acknowledgement is stored in a table. So whatever the decision table we are taking like conditions, rules and actions, so that also a tree, any tree if we are taking, it is unable to classify its behavior until the acknowledgement, whatever the acknowledgement is received or stored in a table. It is also one of the most essential state which defines in the FSM. So the only problem with the essential FSM is nothing but behavior is that it provides lot of work. Whenever behavior changes, it takes a lot of work. That is the most disadvantage, and we can say it is one of the most problem in the FSM. Nothing but essential finite machine behavior is that it provides lot of work just for the sake of branch testing. Every state must be tested, which is not mandatory or essential. So this is about one of the way to define testability tips. So now we'll see some of the conditions of inessential final state behavior. Where these are not satisfied, the behavior of FSM is known as essential. If the behavior can be obtained by parallel program in data flow machine, in that case it is not satisfied the FSM. And if behavior is obtained from decision table or decision tree, we can call it as a essential way, and it is not satisfied if expression of exit is equal to unity of program including loops. Whatever the exit like cases like A case, B case, C case, it leads to the unity of a program. If that is not satisfied, it is not a final state. It is not a essential final state machine. If the program exists, expression is not equal to unity, but we don't want to loop under the looping condition. So this is also one of the way to define the essential final state machine. And these are all not satisfied, then the behavior of FSM is known as essential FSM. So all can be defined. So last is nothing but a guidelines. Whatever the guidelines to be followed to build the FSM or finite state measure into the program code. So first, defining the implementation of FSM, which done in both software and hardware. First of all, you have to define how the FSM is built in both software and hardware. So that is the mainly way to define, and start the designing and check it for the requirements. So designing waste space will be performed and requirements to be checked, and the third step is nothing but analysis should be carried out in the form of state graph or state table with 3 or more states. So minimum there should be 3 or more states, and defining the state graph or state table. Then design the state machine explicitly, clearly and understandable. So the test must be conducted thoroughly to determining the process time and space of explicit. If time or space is affecting the overall system, then use shortcuts to complete the design process. So using the shortcuts is the best way to perform the FSM into our program code. So last one is, if there are more than dozen states, then construct a hierarchical design. So we have hierarchical design way also. You can construct the hierarchical method. Applying that hierarchical method at the end of FSM, nothing but finite machine will be converted into code. So these are all some of the guidelines to be followed whenever the state testing is performed, and these are all some of the tips also, nothing but testability tips we can call it as testability tips. And this is the end of Unit 5 Part 1. Hope you all understand about this state testing. So thank you very much.